Welcome pre-cal students to the review sheet up video, page 198, page 165. Let's go ahead and get started with the problems. Let's first of all take a look at numbers 37, 37 and 41. 37 and 41. Use long division to divide. So we're going to use long division to divide numbers 37 and 41. So 3x minus 2 is what we call your divisor. If I get my pen to work here, there we go. And the dividend is this number right here. And here are the steps that I gave you. I said number 1, make sure this is written in standard form. Number 2, make sure this is in standard form. Other than that, we're pretty much good to go. Divide first term into first term, okay? So 3x goes into 24x squared, 8x times. Now take this and multiply it by all your terms over here. So 8 times 3 is 24x squared, and 8x times negative 2 is negative 16x. Now, I put that negative 16x right here because it matches with this term right here. We then change the signs and we combine. So 15x. Now, I usually don't bring down the next term, I wait. I divide first term into first term. So I'm going to put a 5 right here. And my pen is not working here. Hold on one second. Slide this over here. And here we go. So 5 times 3 is going to be 15x. And 5 times negative 2 is negative 10. And then bring down your negative 8. They're like terms. And this will be a negative, this will be a positive. These cancel and you're left with positive 2. Now you know you're finished for a couple reasons. First of all, you've used all of these terms up here, every single one. Number 2, your degree here, which is x to the 0, your degree here is smaller than your degree right here. This is a 1 degree. And so you know you cannot divide a 1 degree into a 0 degree. So you have a remainder of 2. So plus 2 over 3x minus 2. And there's your answer. Let's try this again on number 41. Okay, your divisor is x squared plus 2 goes outside your box. Your dividend goes inside the box. X to the 4th minus 3x cubed plus 4x squared minus 6x plus 3. Alright, so we do not need this. Let's go ahead and get rid of this. Check it and make sure everything's correct. Looks good. And let's slide this up so we have a little bit of room to work with. And here we go. First of all, make sure this is written in standard form. It is. Make sure this is written in standard form, and it is. So divide first into first. That would be x squared. X squared times x squared is x to the 4th. X squared times 2 is 2x squared. Now be sure and put that underneath the term that it matches, okay? So change your signs. Negative. Make that negative. And then we add. These cancel. There's like a 0 here. So this plus this would be this. And 4 minus 2 would be let me fix this here. 4 minus 2 would be 2x squared. Now I usually don't bring anything down until I need them. Divide first into first. That would be negative 3x. Negative 3x times x squared is negative 3x cubed. Negative 3x times 2 is negative 6x. Now I'm not going to put the negative 6x here. They're unlike terms. I'm going to put it over here. And then bring down this term because it matches it. And then once again change signs and add. Make this positive, make this positive. Put a big 0 here. These cancel. 2x squared. And these cancel. So x squared goes to 2x squared. Positive 2 times. 2 times x squared is 2x squared. 2 times 2 is positive 4. Okay, that's going to match up with 3. So bring down your positive 3. And here we go. Change your signs. there's some good long division practice. Moving on to the next number, number 43. The directions say for 43 and 45 to divide by using synthetic division. So here we go. First of all, your divisor right here does fit the format. It has to be a binomial, power of 1. And this has to be a constant term. Everything's good, okay? So I'm going to put, you always change the sign of this, so I'm going to put a positive 2/3 right here. Now, next, you look at this number here, your dividend, make sure that it's in standard form, and see if you have to add these zeros. 4, 3, 2, 1. There's no constant term, so we will have to put a 0 here on the end. So we're going to go 6, negative 4, negative 27, positive 18, and then a 0. Bring down your 6. Multiply, you get a 4. Combine, you get a 0. Multiply, you get a 0. Combine, you get a negative 27. Multiply, you get a negative 18. Combine, you get a 0. Multiply, you get a 0. And 0 plus 0 is 0. So this was an x to the 4th. So this will be an x to the 3rd. So you have 6 x to the 3rd. 0x squared, there's really no need to include that, and then minus 27x. And of course this would be your constant term here, and then this would be your remainder. So if you wrote the whole thing out, it'd be 6x cubed plus 0x squared minus 27x plus 0x, and the remainder is 0, so plus 0. There's no need to write all of that, although you're welcome to. I don't mind that, but the best answer is to write it just like this. So there you go. Synthetic division can be used in place of long division. Alright, moving on to 45, same thing. Notice my divisor fits the format. Binomial, it's a linear factor, and so I take my constant term here, change the sign, and put that right here. And then here we go. Am I missing any terms? 3, 2, 1, constant term. So no, I am not missing any terms. And so I am totally good with just putting the numbers, the coefficients to negative 19, positive 38, and 24. We're using this to replace long division. Bring down the first number. Multiply. Combine. Multiply. Combine. Multiply. Combine. Alright, so this 2 here was an x cubed. We know that from right here. So our answer is 2x squared minus 11x minus 6. And there's no remainder. So there you go. You see, students, don't forget, synthetic division can be used to, in place of long division. Okay? And so that's another use of synthetic division. Another use of it is to evaluate numbers, and that's what we're going to do here. Now your notes said to do letter A only, but did you know you can take this number here, and instead of substituting it in for x, everywhere there's an x, which does take a lot of time, you can actually use synthetic division to help you evaluate this function at negative 3. So let me show you. We're going to evaluate it at negative 3. So we're going to put a negative 3 here. And then we see if we're missing any terms here. 4, 3, 2, 1 constant term. So we're not. So we have a 1, a 10, a negative 24, a 20, and a 44. Notice that when you're using synthetic division in place of long division, you change the sign of this number. Negative 4, positive 4. Negative 2/3, positive 2/3. However, when you're evaluating a function at a given number, you do not change the sign of the number at all. So let's see what happens. Bring down your first number. Negative 3 times 1, negative 3. Combine, that's a 7. Multiply, negative 21. Combine, negative 45. Multiply, that's a positive 135. Combine, we get 155. Multiply, that's going to be a negative 465. And then combine, and you'll get a negative 400. somewhere. But anyways, let's pretend that I didn't. You put negative 3 in, and you get out negative 421. That's really helpful, okay? When it comes to evaluating functions at a given value. Let me check my work here real quick. 1, 4, 3, 2, 1, 44, a 1, a 10, negative 24, 20, 44, negative 3, multiply, combine, multiply, combine. It looks like it's accurate, so, okay, we're going to go ahead and move on. But that is using synthetic division to evaluate a given function at a given value, alright? Okay, number 51. The directions for 51 say to verify the given factors. To verify it, so we're going to make sure x minus 4 is truly a factor. That's number 1. So how do you make sure x minus 4 is a factor? Well, you put a positive 4, because what would make this parentheses a 0 right here? A 4 would. So if, listen to me students carefully, if x minus 4 is a factor of this polynomial function, then 4 is going to be a 0. We understand that. So I'm going to put 4 in, and I should get out 0, so I'm going to verify that this is truly a factor. I'm going to do that right now. I should get out 0. So here we go. Bring down your 1, multiply, combine, multiply, combine, multiply, combine. Yes, we got out a 0. So we did step A, check, we confirmed that's a factor. Now I'm left over with 1x squared plus 8x plus 7. Now let's see what else it says to do. B, find the remaining factors. Okay, no problem. I'm left over with this. I can factor this so quickly and so easily. What two numbers would multiply together give me 7? When add together give me 8. Well, 7 and 1. Multiply those, you get 7. Add those, you get 8. So the other factors will be x plus 7, x plus 1. Don't forget this factor up here, x minus 4. There we go. Now let's see what else it says to do. Use your results to write the complete factorization of f. Okay, we did that. We did the complete factorization. So here it is right here. Slide this over a little bit. There's the complete factorization of this right here. F of x. So there we go. Complete factorization. Letter D says list all the real zeros, okay? 4 is the 0 for this parentheses. Negative 7 is the 0 for this parentheses. Negative 1 is the 0 for that parentheses. That's pretty simple. And then E, confirm your results by using a graphing utility to graph the function. Okay, I'm not going to take time and do that because you couldn't see me do it on the screen anyways, but you would type this into your grapher, hit graph, and the graph should cross the x-axis at 4, negative 7, and negative 1. Okay, because remember, if these numbers are truly 0, then these numbers are also truly x-intercepts. Alright, moving on to number 53. Now it looks like we're doing the exact same thing for 53, so just... Now students, they give us two factors, so the 0 for this factor is negative 2, the 0 for this factor is 3, so I'm going to start off with negative 2. Letter A says to confirm that these are factors, so 4, 3, 2, 1, whole numbers, so no missing terms. So let's confirm that negative 2 is a 0, or in other words, confirm that x plus 2 is a factor. Multiply, combine, multiply, combine, multiply, combine, multiply, combine. So there we go. Check. That one checks. Now take what you're left over with. This is x to the 4th. So now we're left over with x cubed minus 6x squared plus 5x plus 12. Now listen students, you are so more than welcome to use the original function to check 3. But why would you want to do this? Look how we're breaking this thing down. It was 4th degree. Now it's 3rd degree. Let's use our 3rd degree. Let's use our 3rd degree polynomial here, and let's use that to verify 3. So put a 3 here, and we're not missing anything. 3, 2, 1, constant term, so 1, negative 6, 5, 12. We should get out a 0 here. If x minus 3 is truly a factor, bring down your 1, multiply, combine, multiply, combine, multiply, combine. So now we're left with, this was an x cubed, now we're left with x squared minus 3x minus 4. We just confirmed this. Man, we're doing great. Now, letter B, I think, says to find the remaining zeros. Well, all you have to do is factor this. That's pretty simple. So, what two numbers multiply together give you a negative 4. When added, give you a negative 3. Well, it's going to be these two. Multiply them, you get negative 4. Combine them, you get a negative 3. So we factor this and we're finished. So there's those factors. And then don't forget, we have some other factors right over here to go along with it. And that's what part C says to do. Part C says to write the complete factorization. So there's the complete factorization right there. Look at that. Now on to part D. List all the real zeros. Well, I mean, okay, 4 is a 0 for this parentheses. Negative 1 is a 0 for this parentheses. Negative 2 is a 0 for this parentheses. 3 is the 0 for this parentheses. And then lastly, check it on a graphing calculator, which I'm not going to do, but you can do that. Type this whole original expression into your grapher and hit graph, and the graph should cross the x-intercept at these four numbers. Alright, moving on to number 59. Now we're looking at number 59. Let's see here, 59 and 61. The directions say to write the complex number in standard form. Standard form, okay, no problem. First of all, you always take care of the negative and the radical first. So make this positive and put an I right here. Now the square root of 25 is 5, so 3 minus, bring down your 3, bring down your negative, 5i, and you're done. That's it. Remember, standard form of a complex number is a plus bi. So in this example, my a is 3 and my b is negative 5. Okay? Alright, there we go. So we did write it in standard form. Number 61, same thing. Let's write this in standard form. Now, everywhere you see an I squared, you can really put a negative 1. So I have plus negative 1, I squared, negative 1. Now, a positive negative is a negative 1, and then swap places. So we have it in a plus bi form. Negative 1 first, negative 1 first, and then minus 5i. And there, that's written in standard form. So those are pretty simple, okay? Alright, moving on. Now students, for numbers 63, 65, 67, 69, and 71, so all of those, 63 through 71, the directions say to perform the operations and write the result in standard form. So, here we go. Okay, we're subtracting two complex numbers. So, there's a positive sign in front of this parenthesis, so this just stays the same. There's a negative sign here, so we multiply the negative sign through. Negative times a positive is negative. Negative times a positive is negative. Alright, now let's go ahead and write our common term. Let's combine like terms. I have square root of 2 over 2 minus square root of 2 over 2. So that's going to give you 0. They're going to cancel out, so you have 0. And now your I terms, negative square root of 2 minus square root of 2. So really it looks like this, students. Now watch, there's a 1 in front of this and a 1 in front of this. So you have negative 1 square root of 2 minus 1 square root of 2. So that's negative 2 square root of 2 all over 2. Students, listen to me. Remember, when you're adding or subtracting fractions, you do not add or subtract the bottom. You make sure you have a common denominator, and then you combine the two fractions, okay? So, they have a common denominator here and here, so it stays the same, and then you combine the numerators. So a negative 1 square root of 2, negative 1 square root of 2 is a negative 2 square root of 2. Don't forget your I. Now, I don't care if you put the 0 or not, that's totally up to you. So you can write it like this for your answer if you want to, or you're more than welcome to write your answer like this if you want to. Either way is acceptable in my book. Alright, so number 65, here we go. What we take, we have a binomial times a binomial, so we take our 1 and we distribute it through the other parentheses. So 1 times 5 is 5. 1 times negative 2i is negative 2i. Now we take the 6i and we distribute it through the other parentheses. 6i times 5 is positive 30i. And a positive times a negative is negative. 6 times 2 is 12. I times I is I squared. Now students, in place of the I squared, we're going to put a negative 1. Alright? And we all know that a negative 1 times a negative 12 is a positive 12. And now we're ready to combine like terms. Positive 5, positive 12, positive 17, negative 2, positive 30, positive 28i. So there we go. There's the number written in standard form. Alright, number 67. My suggestion for this would be to put the I and then a big parentheses and then multiply your binomials together. Take your 6 and multiply it through. 6 times 3 is 18. 6 times negative 2 is negative 12i. Now take your positive I and multiply it through. I times 3 is a positive 3i. I times negative 2 is negative 2i squared. Okay, so there we go. Now we all know that I squared is a negative 1. And we know a negative 2 times a negative 1 is a positive 2. So there we go. Now combine your like terms. 18 and 2 is 20. Negative 12 and 3 is negative 9i. And then of course we have an I on the outside to multiply through. I times 20 would be 20i. And I times negative 9i is negative 9i squared. Now, we know that I squared is really a negative 1. And negative 9 times negative 1 is a positive 9. So write this in standard form. Your real number comes first, and your imaginary number comes second. And there we go. Alright, moving on to number 69. Now students, at number 69 here, you have been taught that whenever you have a complex number divided by a complex number, the best way to simplify it and write it in standard form is to multiply the top and the bottom by the conjugate of the denominator, and the conjugate of the denominator is 5 minus I over 5 minus I. Now, let's do the denominator first. That's simple. I've taught you when you're multiplying two conjugates, there's a shortcut. Multiply first times first and last times last. Now that shortcut only works when you're multiplying conjugates. 5 times 5 is 25. Positive I times negative I is negative I squared. Of course, I squared is a negative 1, and a negative times a negative 1 is a positive 1, which would then give you 26. Alright, so 26. Now for the numerator, take your 3 and multiply it through the other parentheses. 3 times 5, 15. 3 times negative I, negative 3i. Now take your 2i and multiply it through the parentheses. 2i times 5 is a positive 10i. 2i times negative I is negative 2i squared. Obviously I squared equals a negative 1, and negative 2 times negative 1 gives you a positive 2. So your numerator becomes positive 15, positive 2, 17, negative 3, positive 10, positive 7i, all over 26. So the proper way to write your final answer is 17 over 26 plus 7 over 26i. And that's standard form of a complex number. Alright? Alright, let's continue on. Alright, students, moving on to number 71. And here we go. Now, personally, students, I don't know what to say here. There's different thoughts on this. You can get a common denominator. I think, personally, to be dead level honest with you, I would rather very quickly take 1 over 2 plus I and simply multiply the top and the bottom by 2 minus I. 2 minus I. I think that's a lot faster, and you'll get this. Of course, the shortcut for your conjugates would be 4 minus I squared. I squared is a negative 1, so you have negative negative 1, which is plus 1. So your whole denominator becomes 5. Then up top, 1 times 2 is 2. 1 times negative I is negative I. So you end up with 2 fifths minus 1 fifth I. Look at that. Now, this whole thing here goes right in place of this here. Got it? And then we're going to bring this negative sign down and then go from there in just a minute. Alright, let's erase. Let's grab this here. Let's pull it down here out of the way. Now let's erase this and let's work on the next. The next fraction here, don't worry about the negative sign. We're just going to take 5 over 1 plus 4i and multiply it by 1 minus 4i. Okay? And here we go, of course, the denominator. 1 times 1 is 1. 4 times 4 would be a negative 16i squared. I squared is a negative 1. Negative 16 times a negative 1 is a positive 16, which would then give us a 17. For the numerator, 5 times 1 is 5. 5 times negative 4 is negative 20i. Okay, so this whole expression here goes in place of this. Okay, this whole expression here, which is 5/17 minus 20/17 over I, this whole expression here takes the place of this. So the only thing we need to put between these two would be a minus sign from right here. Okay, so we've done a really good job of breaking this thing down now into a very reasonable problem. So let's take these two expressions. Let's go ahead and face the problem. There's a positive sign out in front of this parentheses, so your 2/5 stays 2/5, and your negative 1/5 stays negative 1/5. Take your negative sign here, multiply it through. That gives you a negative 5/17, and a negative times a negative gives you a positive 20/17 I. Now, use your calculator, students. All of your scientific calculators have a fraction button, okay? So we're going to take 2/5 right here, minus 5/17. So, 2/5 minus 5/17, and it gives you 9/85. That saves a lot of time. Now, a negative 1/5 plus 20/17, those are your I terms. So negative 1/5 plus 20 divided by 17. And you will get 83/85 positive I. There we go. Alright, students, so really not too difficult, okay? Alright, moving on to the next one, which is numbers 77, 79, 81, and that's where we'll stop the first video, okay? Determine the number of zeros of the function, then find the zeros. Now, I'm not sure if they're counting repeats or not. If they're counting repeats, the number of zeros for this would be 3. X minus 4 is a linear factor. X plus 9 is a linear factor. Then because this power of 2, you write that linear factor again. Now on a test or a quiz, on your upcoming test, I'll be really clear as to what I want. For now, I'm going to include the repeats. So how many zeros does this thing have? 3. Really, it has 2, but I'm including the repeats. Alright, so we have 3 zeros. Now next, it says to determine the number of zeros of the function, then find the zeros. So 4 is a 0 for this parentheses, negative 9 for this parentheses, negative 9 for this parentheses. If you disagree and you put 2 zeros, no problem. It's not a big deal to me. Number 79. Now here, they didn't factor it for us. So I'm going to say 0 equals x squared plus 6. Now, students, the directions say once again, it says determine the number of zeros. It does not say determine the number of real zeros. So we can include imaginary zeros and everything, okay? So, because this group here has a power of 1, that's 1 0. Because this group here has a power of 2, that's 2 more zeros. So I know I'm going to have a total of 3 zeros. Now let's find them, okay? For this group here, 0 makes this group become 0. So 0 is one of my zeros. Now for this group here, we're going to take it, set it equal to 0 and solve. Bring the 6 over and make it a negative 6. Now you see why I mentioned imaginary zeros. Take the square root of both sides, and we get plus minus the square root of negative 6. And of course we can't have a negative number, so we make it positive and put an I on the outside. So there's my other two zeros. Square root of 6i, negative square root of 6i. Okay, students, so there we go. Pretty simple. Number 81. Now here, my picture cut off. It was x plus 3 minus I believe no, that's incorrect. X minus 3 minus I. So if you'll look in your book, you'll see this other parentheses. Alright? Now, they want us to tell how many zeros there are. Well, look, students, is this linear? Yes. Is this linear? Yes, but notice there's a power of 2 right here. So keep that in mind. I'll tell you what, on the one back here, we included the repeats. On this one, we won't, so we'll do it 2 ways. Here we have a linear factor and a linear factor. I know those are all linear because all the x's have a power of 1. So I have how many zeros? 1, 2, 3, 4. I have 4 zeros. Now let's list out those 4 zeros, okay? For the 0 here would be a positive 8. The 0 for this parentheses would be a positive 5. The 0 for this parentheses would be, change the sign of both of these, positive 3 minus I, okay? And the 0 for this parentheses would be, change the sign of both of them, 3 plus I. Okay, so there's your 4 zeros. Now if you want to condense these two and write them as 3 plus minus I don't care, but that's still 4 zeros. 1, 2, 3, 4. And all of that, of course, is up to you. Okay, so there we go. That's a good stopping point for the first part of the review sheet video. Hope this has been a help to you. If you have any questions, don't hesitate to call or email.